Okay, welcome back. Hey, it's good to see you again. Well, I don't actually see you, but I can talk to you anyway. Here we're going to look at how energy is changed, and we call a change a transfer. So transferring means we turn one thing into another thing. And in this case, we're turning energy from one form to another. Now, remember the law of conservation of energy? That the energy we start with, the amount of energy we start with, and the amount of energy we finish up with must be identical. We can't destroy it, we can't create more energy. So let's look at this example. We've got a cyclist and he's riding up the hill. I love his orange jumper and his blue shorts. Now he's going up the hill, and it says that he starts off with he's moving, so he has a type of energy called kinetic energy. But as he goes up the hill actually gives him more energy. So the height above the ground, or the height above the Earth's surface as he climbs the hill, gives him more potential energy. Now potential energy is energy that is not really visible, but it's there. And it's there that we can use at some stage. As he goes down the other side, that potential energy turns into kinetic energy and he races down that hill. So we can do what's called an energy diagram, and I've got one down the bottom. And we're going to do this energy diagram down here. On our way up, he changes kinetic energy into potential energy. But not all of his kinetic energy is converted into potential energy, because we all know that when we are cycling, we get nice and hot. So maybe an energy is formed that is not super useful to us in terms of bike riding, and that's heat. And that is energy that is not useful at the moment. So the useful energy we're going to get out of this is the potential energy that is going to let us coast down the other side of the hill without having to use too much of our own. But we're going to have to use lots and lots, put lots and lots of kinetic energy in to reach the top. So this would be our energy equation. The blue line, or the blue arrow, tells us the useful energy, and if we look at the arrow that comes down, the red arrow is our arrow that is showing us which energy, or energies, remember it can be more than one, that is not as useful as our blue arrow. Alright, so let's complete this on our next slide by looking at what goes on. So again, let's fix this up. So in this case, we've got kinetic changes into potential. Now, normally we would call this, because it is being higher up, and we're going to use the ability of us being higher to generate some more kinetic energy. We call it gravitational potential energy, because gravity helps us convert that potential energy into kinetic energy. And we are above, we're higher up, and the higher up we are, the greater gravitational potential energy we have. Now, we said that both the cyclists and the bike tyres are going to get hot, so we are probably going to have some energy we're not really useful to us, which is heat energy coming out, and that's shown in the red arrow. So let's look at what goes on the way down the hill. So on the way down, we start off with, in this case, we've got GPE, or potential energy. And as we see, we convert it into kinetic energy. And I think you would find that even though we're riding downhill, we do still get hot. And more importantly, the bike tyres get hot. So we could say that we're probably going to have some heat energy left in here. So in our first case, if our energy equation, and using our whole idea of what's going on. The total of our kinetic energy is going to be equal to how much GPE we end up with plus how much heat. Right, in the bottom, coming back down, it is going to be the reverse, and it's going to be the GPE we start off with is equal to the kinetic energy of us moving down the hill, and of course the heat energy of our tyres warming up. I hope that's making a bit more sense, and I hope you understand energy a little bit better because of it.